Here's a video of an example problem that's very similar to something that you'll have in your written assignment, where we're asked to graph a cosine function. Before I begin, let me apologize in advance for my handwriting. I'm using a writing template, one of those deals where I look at the screen while I'm writing somewhere else, and I've gotten better than I used to be, but it's not going to be the prettiest picture in the world. I'll do my best. Okay, when we're asked to graph a sine or a cosine function, I like to first handle the horizontal transformations. So I'm going to deal with everything inside of the function by setting up an inequality. The inequality is going to give us the starting and stopping x values for one complete cycle of the graph. I'll then look outside of the function to consider what vertical transformations need to be applied. So really I'm going to graph this in two steps. I'm going to first graph the function y equals cosine of 1/2 x minus pi over 4. I'm going to ignore everything outside of the function. And then in step 2 we'll talk about what vertical transformations need to occur. Now, before I set anything up, it would be helpful if you recall your basic graph of either sine or cosine depending on the problem. So in this problem, it's nice if we can, at this point, visualize the basic shape of the graph of y equals just plain old cosine of x. So I'm going to jot down a really rough sketch of that graph off to the side. Now we get one complete cycle of the graph of y equals cosine of x as x goes from 0 to 2 pi. Cosine has an initial value of 1. Cosine of 0 is 1. And cosine of 2 pi, again, once we end our cycle, will end at 1 again. In the middle of the graph, so in this case when x is pi, the y value dips down to -1, the minimum value for this graph. Halfway between 0 and pi, so when x is pi over 2, the y value is 0. The graph crosses the x-axis. And again, halfway between pi and 2 pi, the graph will cross the x-axis again. So that's when x, here we go, pardon my handwriting, I'm sorry, but 3 pi over 2. Hopefully you're familiar enough with the basic graph of cosine of x that you don't need to see that. You know what it means. Or you know what that x value is. Okay, so I'm going to go through those points and sketch the basic graph of y equals cosine of x. Now, the really important point right now is that we get one cycle for the graph of y equals cosine of x when x goes from 0 to 2 pi. Those are the starting and stopping values for one cycle of our basic y equals cosine of x. So, similarly, we'll have one cycle for the graph of y equals cosine of all this, 1/2 x minus pi over 4, when that quantity, 1/2 x minus pi over 4, goes from 0 to 2 pi. This is what's in place of the x in this function. Instead of y equals cosine of x, we have y equals cosine of all of this. So our one cycle will occur when that argument, that's the word for what's inside of your trig function, 1/2 x minus pi over 4 goes from 0 to 2 pi. So we now wish to isolate x. Once we have x isolated, we'll have our starting and stopping values for one complete cycle. Now when I'm solving an equation or an inequality with fractions like this, if you're uncomfortable with fractions, one way to handle it is to multiply, I'm going to box out this here, is to multiply across the equation, or in this case inequality, by the least common denominator, LCD, which in this case is 4. So I'm going to multiply each part of this inequality by 4. Okay, so my new inequality has 0 less than or equal to, well, let me skip the middle part, we'll skip the hard part for now, not that it's not hard, but the more difficult part. And 2 pi times 4 gives us 8 pi. Okay, now if I distribute the 4 to both parts inside, well, let me write this step. So 4 times 1/2 x minus 4 times pi over 4, 4 times each part. So we have 0 less than or equal to, let's see, so the 2 cancels here and leaves 2. 2 times x, 2x, minus 4 times pi over 4, those 4's cancel, so minus pi, and then we still have the 8 pi out here. Now again, we wish to isolate the x, so now I'll add pi across the inequality. So I have pi is less than or equal to 2x is less than or equal to 8 pi plus 1 pi gives me 9 pi. And one last step to isolate x, divide across the inequality by 2. So we now know that one cycle for the graph of this function, here, let me clear up the word cycle for you. One cycle will occur when x goes from pi over 2 to 9 pi over 2. We are now ready to start marking x values for our graph. So I'm going to start marking values on the x-axis. And here I want to stress the importance of labeling values on each of your axes. You're going to be asked to graph a trig function by hand on your midterm. And there too, your instructor's going to want to see your work. And they're also going to be looking for values on each axis. You'll have instructions very similar, if not exactly like the instructions you have in this problem. Okay, now there's a reason that the increments are not marked ahead of time, and that's for your convenience. Once you solve the inequality, we can make these increments on the x value whatever we need them to be. So if our cycle had gone from pi over 3 to 7 pi over 3, then we could count by thirds on the x-axis. In this case, we're going from pi over 2 to 9 pi over 2, so I'm going to make the increments pi over 2. So the initial value, the starting x value for our little u shape, for our graph of cosine of x, is going to be pi over 2. And our stopping value is 9 pi over 2. So I'm just going to count. Here's 1 pi over 2. Here's 2, 3, 4, 5, 6, 7, 8, 9. So here's 9 pi over 2. Now, I realize that there are vertical transformations that we're ignoring, but in the graph of what I'm graphing here in step 1, y equals cosine of 1/2 x minus pi over 4, I'm going to use the same y values that we have for our basic cosine of x. We're not doing any vertical transformations here. So for our starting x value, our initial y value is 1. So I can go ahead and mark this point. And our final y value is 1 again. And again, I'm getting these y values from just my understanding of the basic shape of y equals cosine of x. I know that for my first x value, y should be 1, and for my last x value, y should be 1. Now in the middle, y should be -1. So in the middle, well, let's see. Here I happen to have 8 spaces between pi over 2 and 9 pi over 2. So I'm just going to count. I can find the middle by counting over 4 spaces. 1, 2, 3, 4. And my y value should be -1 here. Halfway between the 1 and the -1, the graph crosses the x-axis. So if I have 4 spaces, if I just count over 2, there's halfway, the graph is going to cross the x-axis. Here again, between the -1 and the 1 and the second half of the graph, halfway, the graph will cross the x-axis if I just count over 2 spaces. And I'm going to draw a dotted graph here. Now at this point, I have graphed the step 1 function here, the y equals cosine of 1/2 x minus pi over 4. I still need to apply the vertical transformations. Before I do that, I do want to take a moment. It was kind of convenient here that we had an even number of spaces, so I was able to just count over 4 spaces to get my middle x value and count over 2 spaces to get these x-intercepts. if those values are not as obvious, so to find those intermediate x values, there is a formula for doing that. We need to first consider the period of the graph. And there are really two ways for us to come up with the period. One is to remember that formula, 2 pi over the absolute value of b, that gives you the period of sine or cosine. So in this case, that's 2 pi over our coefficient of x, which is 1/2. And instead of dividing by a fraction, we can always multiply by the reciprocal. So 2 pi times 2 gives us a period of 4 pi. Now notice that also if you blank on that formula, we have the starting and stopping values for one cycle of the graph. We know that one cycle occurs as x goes from pi over 2 to 9 pi over 2. So the period is just the length of that cycle. So to find the length of that interval, we take the last x value minus the first x value, and that'll give us the length of the interval. We already have a common denominator of 2, so I can go ahead and subtract the numerators. 9 pi minus 1 pi gives me 8 pi. And when I divide by 2, I get 4 pi. So that's just a way of sort of checking that everything's lining up the way it should. We use both the formula and the length of the interval. Now, when determining these key x values, so these intermediate x values, where exactly is my graph crossing the x-axis? Suppose we need those values. Well, let's think. I have 5 key points on my graph. I know that the first point occurs when x equals pi over 2. And I'll set up my 5 values down here. I know that the last key x value should be 9 pi over 2. So we have the first one, we have the last one. We want to find these intermediate x values, x2, x3, x4. The way you find those is you take the previous x value and you add the period of your graph divided by 4. Because if you think about it, when I graphed plain old y equals cosine of x, I really looked at 4 sections of the graph. So that's why we're dividing the period by 4. So in this case, we want to add 4 pi divided by 4. So in each step, I want to add a whole pi. Okay. Let me switch colors here. Alright, so my first x value is pi over 2. To get the next x value, I take the previous value, pi over 2, and add that period over 4. So we're adding that pi to get the next x value. Now, it might be nice here if I had a common denominator, so instead of adding pi, I'll write that as 2 pi over 2. So that's still pi. Now I have a common denominator of 2. And I can simply add the numerators to get 3 pi. 3 pi over 2. The next x value, okay, well we take the preceding x value, 3 pi over 2, and I add pi. Now I know better. I'm going to go ahead and write it with that common denominator, 2 pi over 2. So the next key x value is 5 pi over 2. Again, to find the next key x value, I take the previous x value and add pi. So I'll write as 2 pi over 2. And that gives me 7 pi over 2. Now note that if I added 2 pi over 2 again, I would have 9 pi over 2. So again, it's nice when everything lines up in that way. Now, I don't want to clutter my graph too much. I guess I'll label, so the second key x value we know now is when x is 3 pi over 2. And then this next key x value, this might get a bit hard to read, but it's when x is 5 pi over 2. And the next key x value is when x is 7 pi over 2. So now we have all of those intermediate x values. And this method, again, I realize that a lot of you guys could have found those values just by counting by pi over 2's. But if we had something more awkward like pi over 3 as our period, it gets a bit trickier finding those intermediate x values. So you can use this adding the period over 4 to each preceding x value. Okay, we have our x values, we have the basic graph with the horizontal transformation. The last thing we need to do is perform the vertical transformations. And I'm going to move up here above. So step 2, I want to graph the actual function that we were given. 3 minus cosine of, and we've dealt with the 1/2 x minus pi over 4 when we solved the inequality. It's this 3 minus that we're worried about now. Now let me write this a different way, and it might be a little more comfortable for you, make it a little more comfortable for you to identify the vertical transformations. I'm going to move the 3 to the end. So I have, think of this as -1 or negative cosine, so there's a multiple of the cosine function, minus pi over 4, and then we've got positive 3. Now note that this is the same as what I have above. I could just move the 3 in front. I'd have positive 3 minus cosine of 1/2 x minus pi over 4. When we write it this way, it might make it a bit easier for you to see the transformations. When we have a negative outside, out front, that's a vertical reflection. So it reflects across the x-axis if you reflect vertically. And the plus 3 out here shifts each point up 3 units. Again, I apologize for my handwriting. Now you might remember that we should always perform vertical shifts up or down. We should do those last. So I'm going to do that as step 2. I'll reflect across the x-axis as step 1. So for each of the points on my graph down here, I'm going to reflect across the x-axis and then shift up 3 units. So I'm going to just move the graph point by point. Sorry, I had a problem locating my cursor here. Okay, so I'll do my final graph in blue. Okay, so let me start with this initial point. Now the x value is going to stay the same. We're done with the horizontal transformations. I'm only applying vertical transformations. So wherever I move this point, it's going to stay on this same vertical dotted line. Alright, so we're going to reflect across the x-axis first. So that'll flip our y value from 1 down to -1. And then from there, shift up 3 units. 1, 2, 3. And we land at this y value of 2. Let me move to the next point. So I'm looking at this point at 3 pi over 2, 0. So y is 0. Reflect across the x-axis. Well, if it's on the x-axis, that doesn't go anywhere. And then up 3. 1, 2, 3. Take this point, reflect across the x-axis. So right now the y value is -1. That'll flip it up to +1. And then up 3 units. 1, 2, 3. Take this point, reflect across the x-axis. That doesn't go anywhere. And shift up 3. And the graph should keep the same shape, so I should be level with that other point that used to be on the x-axis. Take this point, the y value is 1, reflects down to -1, and then shift up 3. 1, 2,